Hello, Mr. Long. This is FRK number 3, part 8. We are trying to, part 8, we are asked to plot the data points for the quantity given in the data table, right? And so I'm just gonna, oops, the wrong one. I'll bring out this graph, and this is part 8. We're asked to graph below the table above. So we are given the two values fn and t. So for fn, we're gonna put it on the y-axis and t on the x-axis, and the reason being is that the force is determined by the time seconds, and then we can just do 0, 1, 2, 3, 4, 5 because it is evenly separated given to us. And this is at 0, it is at 100 or 100. So we can split this 180, 60, 40, and 20, and 0 here. And it says that time t equals 0. Fn is equal to 100, so we put a dot here. At time t equals 1, 80, 2, 60, 3, 40, 4, 20, and 5, 0. And as you can see, this is a very linear, what's it called? Linear graph or function. And so we can just draw a straight line through all the 5 points. And that's part A done. So for part B, we are asked to, using the information given on the table, you are asked to determine expression for ft. So we're trying to find ft, and to find ft, we can just use the formula y equals mx plus b, right? Because ft is a function that is determined by t, and what we know is that we can just use a table that was given or the graph, because that is also the force determined by the time t. And using the y equals mx plus b, we know that y in this scenario is f of n, as we stated earlier, and x, the variable, is t. So all we have to do is replace y with f of t is equal to mt plus b. And how do we find b and t? B and n? Let's start with m, where where m is just the slope, right? So how do we find slope? We can just, m is the slope, and what we know is that we already found the slope. We already have it right here, right? And what we know about this graph is that it shows us the slope that every 1 second passes, it decreases by 20 newtons. So it is negative 20 over 1 second. So that is our what is it called? That is our m, and we can just plug that in. F of t is equal to negative 20 t plus b, and here b is we can just substitute in 0 for f of t, right? F of 0 is equal to negative 20. Yeah, well, we can just put negative 20 times 0, which is 0, plus b. But we know that at f of 0, it is equal to 100. So therefore, f of 0 is equal to b, which is equal to 100. Therefore, b is equal to 100. And now we have b and m. So we have the function f of t is equal to negative 20 t plus 100 newtons. This should be noted as newtons over s, and this should be just newtons. And yeah, you should get rid of that. And that is our formula. For part C, we are asked to derive an expression for the acceleration at of the car. So for acceleration, well, what we know is that f is equal to ma, right? And if f is ft, then if there's a function ft is equal to m times a of t. And the reason why a has is the one with the variable is because m is a constant value, and a is already known to have is already known to be dependent on time, right? So what we can do is just ft divided by m is equal to a of t, and that gives us the acceleration formula. And right here, since we know that f of t is equal to negative 20 n over s plus 100 n, we can just do negative 20 n plus n over s plus 100 newtons. Oh, that's t. 100 newtons divided by the mass, which is given to us, which is 5 kilograms, is equal to A of t. And if we simplify this, newtons is given by meters per second squared. So we just have negative 20 meters per second cubed, as per second, meters per second here, right? Because it's per cubed. That's my bad. Because yeah, newtons is given by meters per second squared, and if we divide that by, so multiply that by s, it becomes meters per second cubed, right? Times t plus 100 meters per second squared is not 100. I forgot to simplify this. This should be 4, and this should be 5 divided by 100. 100 divided by 5 is 20. So 20 meters per second is equal to A of t. For part D, we're asked to find or sketch the acceleration versus time. For part D, we're asked to find and sketch the acceleration versus time graph. And I'll just bring out the same graph from before. So right here, here, same graph, because basically it gives us about the same graph. So what we're gonna do is we know, well, there's two ways to do it mainly. One is to just look at this graph here, and what we know about Fn right here, Fn right here is equal to AT times 5, right? So all we have to do to find the AT graph is divide all of these values here by 5. So what we would get here is 500 divided by 5 is 20. 20, 16, 12, 8, and 4, 0. And the time doesn't change. So what we know about at t equals 0 is that newtons is 100, so we divide that by 5, which is 20 newtons. At 1 it is 80, but divided by 5 is 16. 2, 60 divided by 5, like 13, 12, and so on and so forth. So you just get the same, you get a graph that is similar in shape, right? It's just the magnitude is divided by 5. And the other way to find it is to just use the formula A of t and just plug in each value from 0 to 5, and you can just graph that. So if we use the formula here, negative 4 meters per second cubed times t plus 20 meters per second squared, we can just plug in 0. That gives us 20 meters per second squared. 1, it being 20 minus 4, so 16, 2, 12, and so on and so forth. So those are the two ways you can find it. For part E, we're asked what information can be extracted from the time acceleration versus time graph in part D. So what we can find are two things mainly, which is jerk, because the derivative of the acceleration, which is equal to the slope, right, is equal to the jerk. Jerk, which is denoted what it is. I mean, this doesn't matter. It's just a variable, right? It's a type of function. It's to denote it. But A of t, A delta A prime of t, is equal to G of t, right? The jerk. And what we know about jerk is that what we know about the derivative of a function is that it is just a slope, right? So what we know about the slope is that it is negative 20. So we just know already that jerk is equal to not negative 20, negative 4. So therefore we get jerk is equal to negative 4. And the other thing we know about, which I should write that, we know the jerk of the function or the system because the slope of A of t is given. And the other thing that we can find is velocity. And this is because the integral of A of t dt is equal to v of t. And here it will be v of t plus c. However, we are going to assume here that velocity at the start, so c, will be 0, and so will x of t. And this is done just so that the next few problems make sense and don't make it too confusing. All right. So the other thing we can find is velocity. We know we can find velocity because velocity of the system because the integral of a of t is the velocity, and the integral of a of t can be calculated by finding the area of the graph a of t, graph of a of t under the curve. Gosh, curve. And we know the jerk of the system because the slope of the a of t is I'll rewrite this actually, because we know the jerk of the system because a delta t gives us, or a derivative of t gives us the jerk, or j of t, which where a of t, a derivative of t, a t derivative of at is just the slope of a of t. Alright, so now for part F, we are asked to derive an expression for the instantaneous velocity vt. And what we stated above was that vt can be given by just the derivative, the integral of at dt. And this problem, we're gonna assume that v of c is 0, so we're just not gonna include it here. So how do they find this? Well, what we can do is just get the, well, we already know what we're gonna do, right? We're just gonna find the integral of it, which is negative 4 meters per second cubed times t plus 20 meters per second squared dt. And this just simplifies to t squared over 2, so negative 2 meters per second squared times t plus 20 meters per second t plus c. And as we stated earlier, c would just be 0, so we're just not gonna put that. And so that is our formula for the velocity function. Wait, that seems a bit weird. Meters per second. Oh, this should still be, oh, that's my bad. These two numbers should still be meters per second cubed, but t should be squared here, and that one should be just pt. Because what we know is that t is some sort of second, right? So if we multiply 20 by, like, let's say 1 second times 1 second, then these cancel out and gives us 20 meters per second. Alright, for part G, we are asked, using the known information that can be extracted from the AT graph, so this thing right here, we are asked to find the velocity at t equals 5. Right? You know, determine vt equals 5. So what we know about vt equals 5 is that the integral of 0 to 5 of a of t dt is equal to v of 5 minus v at 0, right? T equals 0, t equals 5. And what we can do here is rearrange this. Well, we don't even have to rearrange it, because we stated earlier that the velocity at t equals 0 is just going to be 0, because we're going to assume that. So we just have v of 5 is equal to 0 to 5 at dt. So what is this integral? Looking at the graph, what we know about the integral is that the integral of a graph is just the area under the curve. So it's just all of this. And since it's a linear function, we can just assume we can find the area by using the triangle formula, which is 1/2 b times h, where base is 0 to 5, So 5. And height is just 0 to 20, so it's 20. So what we get is the area here, all of this, is just 50. So the integral of 0 to 5 of a of t is just 50 meters per second is equal to v of 5. And for part H, we are similarly finding v of t, but instead we're gonna v of t at 5. But instead of using using the graph here, we're gonna use a formula that we found in part F, which is just part G, which is just part F, my bad, which is just -2 is equal to -2 meters per second cubed t squared plus 20 meters per second squared. Meters per second squared and t, right? And what we can do is just plug it in now. Plug in t for all of these. This is the wrong notation. It should be like this. And if we want to find v of t at 5, we now plug in the values. Square of 5 squared plus 20 meters per second squared times 5. This gives us negative, these should be seconds. So that gives us 25 times 2 is 50. Cancel out those two. Meters per second plus 20 times 5, which is 100. Cancel those out, gives us meters per second. And that gives us the value 50 meters per second. So at Vt equals 5, 50 meters per second. And this information agrees with the information we found in from part G, yeah. So the v of t equals 5 found in part G matches with the v of t, the Vt equals 5 found in part H. Alright, so for part I, we are asked to derive an expression for the position function. So we're trying to find x of t. And to find the x of t graph, what we know is that, this is very simple because we already have the velocity of t graph, and the relationship between these two is just that v of t is the integral of v of t dt is equal to x of t, right? So all we have to do is just where's the formula? So this is equal to -2 meters per second cubed t squared plus 20 meters per second squared times t dt is equal to the t becomes t cubed over 3 -2 over 3 meters per second cubed t to the third plus 20 meters per second squared t to the squared over 2 plus c. But we're gonna assume position is 0 as well here, because it makes it kind of hard later on for the next few questions. And also it never states, we're just gonna assume it's 0. So that is the formula for it, which is -0.667 meters per second cubed t to the third plus 10 meters per second squared t to the squared. And now all we have to do is now we have J. Alright, for part K, it asks us to draw or to sketch the position v time graph. So as we said earlier, the x-axis is time given by with the unit s seconds, and x given by units m, because x, or the position, is dependent by the time seconds, right? So we are asked to find it from 0 to 5, 0, 1, 2, 3, 4, 5, and we'll just put 20, or not 20, 40, 80, 120, 160, and 200, because this will make our life easier. Yeah. So how do we find these quantities? Well, all we have to do is use a function we found earlier, negative 0.667 x squared, or t squared, t cubed plus 10x 10t cubed. So yeah, because x of t is given by negative 0.667 t to the cube plus 10 to the t to the squared. There, that's the formula we got earlier. So all we're gonna do is plug this into the calculator and do second table, and this will give us all the values we need. So it says that at 0, t equals 0, it is 0, t equals 1, 10, so around there. 2, 34, so around here. 3, 72, so around here. 4, around 117, so about 120 right here. And at 5, 166, so around 160, so around here. And we can see this is the slope that we get. And now that we're done with that, it asks us to draw a line that represents the instantaneous velocity at t equals 2. And what we know about the instantaneous velocity is that it is the velocity tangent to the slope at that time. So at t equals 2, the slope tangent to t, the slope tangent to what am I saying? I guess it is still slope tangent to the actual slope, or the formula, right? Is about this. And I'm just gonna estimate here because it just says to draw a line, and we're just trying to represent it. It doesn't have to be very accurate. All right. So for the next, we are asked, or next part, we're asked to find the speed average between t equals 0, 1, 2, 3, 4. So here are two ways to think about this. What we know about S average is that it is given by delta t, or, well, I guess it's given by distance over delta t, right? And here, this is very similar to just the slope of x of t, right? The slope of x of t. The slope of x of t. And what we know about the slope, or that's not slope, I'm sorry, Mr. Long. What we know about S average is that as d increases, right? As d increases, the S average will increase. Wait, what am I saying? Oh, wait, this is the wrong question. All right. So, we are asked to draw a line that represents the average speed between t equals 0 to 1. So okay. I'll go back. Sorry about that. S average is given by d over delta delta t, and this is same as. And since the x of t graph is strictly increasing, right? Increasing, d will always be just delta, not delta. It will always be just xt of f, so xt final minus xt initial, over, and then delta t is just tf minus ti, right? So what we know is that to find the S average between t equals 0 to 1 is just to find xtf. So since tf is 1, so xtf right here, and xti is 0 right here, the slope just gives us the S average, right? Because rise over run, the d is the right here, that's d, and right here, this is delta t. So we just have the S average from 0 to 1, and we can do the same thing for 2, 3, 4, and 5. So x0 to t equals 0 to t equals 2, x t equals 0 to t equals 3, x t equals 0 to t equals 4, x t equals 0 to t equals 5. Just like that. And that gives us the S average for each of those quantities. Now, for the last part of this question, we are asked to clearly explain what happens to the average speed of the car during each second interval. So, what happens from here, 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. So there are two ways to think about this. The first way is to just look at only the graph, because as I stated earlier, the S average is just given by xt of f minus xt of y, which is just a slope, right? So if we draw it from 0 to 1, it'd just be this. This will be the S average from 0 to 1. 1 and 2, it'd just be this. From 2 to 3, be this. 3 to 4, it'd be this. And 4 to 5, it'd be just this. And what we realize about each of this is that the slope gets even slightly bigger, or it just gets bigger in general, right? So, or the slope gets steeper, meaning that S average is getting bigger, because a steep slope means that the change in y over the change in x, and I'm talking about x and y axis here, is great. So the y is very great and x is small. Additionally, since S average is given by the slope from t equals 1, t equals 0, blah blah blah, and so on, since the slope becomes steeper from each time interval, it will therefore become greater. Because as we stated, the S average is just a slope, and since the slope is getting steeper, S average is getting steeper. And the other way to think about this is to let's see. Okay, so the other thing that we know is that using the same formula, we know that each time interval, so delta t, is always going to just be 1 second, right? But the difference here is that d is going to increase as time increases, and this is given by this is proven by the formula right here. If we go to the formula right now, x at 5 minus x at 4 is going to be greater than x of 4 minus x of 3. And to prove it, I'll just do 166 minus 117 and 117 minus 71. And this gives us the two value, 49 and 46. As I said, this proves that x at 5 minus x at 4 is greater than x of 4 minus x of 3, right? And as you can see, since d is greater than 46 and delta t is always going to be 1, we see here that the average speed is greater when the time interval increases. So those are the two ways that I would explain what happens to the average speed of the card during each second interval. Alright, for K, we're asked to calculate the average velocity between t equals 1 to 3. So average velocity, v average, unlike speed, is given by delta x over delta t. And this is in a, what would you call it? In the delta, when you're trying to find speed, it'd be absolute value and whatnot. It would, it wouldn't be delta x, it'd be d for speed. Well, whatever. I don't know why I'm talking about that. Well, anyways, v average is given by delta x over delta t. And what we know about delta x, we can just rewrite this as at x of t final, we'll just use f here, xtf minus x of t initial denoted by I, and we can do tf minus ti. And since we're trying to find the average velocity between t equals 1 to 3, we can just put the final time as x of, so v average from t equals 1 to 3 will be given by x at 3 minus x at 1, 3 second, and x at 1 second, 3s minus 1s. And I still have the formula in my graphing calculator, so I'm just going to use that. And at x of 3, it is given to us as 72, and x of 1 given to us by 9.33. And 3 minus 1, and that simplifies to 62.667 over 2. And, oh, I should write this down. Meters, second. So this is what we're left with, and it is just 31.33 meters per second in the positive x direction. And that's it for this video. Have a great rest of your day.